Hello, everyone. Welcome to a session about security and JDK tools. Of course, we're going to talk about Java as well. I'm very happy to be here in front of you. It's the first time that I'm attending JCon, that I'm in Cologne, and of course, I'm enjoying this beautiful weather, apart from this wonderful conference. I am Anna. I currently work at Oracle as a Java developer advocate. I love to talk about Java, about security, about JDK tools. These are my preferred subjects around Java. And I like to share what I'm doing at work as tutorials or as videos. We'll share some links at the end about what I have done in this domain of security and, of course, working with JDK tools. And of course, you can get in touch with me on social media, on Twitter or on Mastodon. You have the links here in the slide. Let's look a bit what we're going to talk about today. So we're going to start by looking at the JFR security events. That's a small overview. We're going to observe the security properties, and we're going to see what options do we have as Java developers. Going to be a little refreshment there. Monitoring TLS protocol, analyzing the certificates, 6509 certificates, and of course, looking a bit about continuous monitoring in the cloud, so how we can connect all this information in the cloud side. But overall, the goal of this session is actually to learn how to use JDK Flight Recorder, the events, the JDK Mission Control all together so that we can look at the security of our Java applications and detect any potential risks. So, without further ado, let's start the theoretical part because that was going to be needed a bit during the demos. So, the JFR security events overview. Now, JDK Flight Recorder is, in its events, as probably some of you know, it's a JDK tool and is great for inspecting a running Java application and see what's going on with it and its underlying JVM. But moreover, is great for profiling because we can store events that are about our Java application and its underlying JVM in a JFR file. And usually these events have these components that are in the slides here. So there's an event ID, a timestamp, when that occurred, a duration for the event, a thread ID that one is connected, stack trace ID, and of course an event-specific payload, and that varies by events. But most importantly, this .gfr file that holds this kind of events holds also data necessary for resolving preceding events and metadata on how we can interpret these events. So let's look at the specific events for security, because at the moment there are about 150 JFR events. This session is going to be about the security events. Now, the security events we have at the moment available are listed in the slide. And why do we need them? Because, well, they help us to monitor the underlying security configuration of our Java application, and they give us insights over the overall strength of the cryptographic standards that our application is using. Now, JDK 12 has introduced 4 JDK Flight Recorder events, and I listed them chronologically. So the first 4 are from the JDK 12, and the last 2 are from JDK 20. Now, these security events, the first 4, are disabled by default in the default.jfc and profile.jfc configuration files that are shipped with the JDK. However, while these are important to help us understand the modifications that occurred over security properties, or look about the successful TLS handshakes, or the certificates that were negotiated successfully in those specific TLS handshakes and their details, in JDK 20, 2 more events were added. One that is about looking at the initial security property that a Java application has. Because we had the security property modification, we can trace what was modified, but why not look what was before, like what was initially? And of course, there's one about inspecting on the invocation of the security providers that are involved within our Java application. So we can also trace which security providers are there to give us the cryptographic standards that our application is using. And also in the slides, you have to which versions these were backported to, because when they were introduced, they were also backported to other versions so that the one that are vendor supported also have them included. So without further ado, let's start by looking at the JDK security properties. And there are a few ways that we can have at hand as Java developers to look at the security properties. Now, the first one that the first mean that we have is looking in the Java home conf security file and look at what initial properties we have there. But then we have the option to dynamically set these security properties using the Java security class. And of course, we can print them all the time with the property minus the Java security debug with the value properties. However, a better idea in looking at the initial security properties, if we want to correlate them within the monitoring tools, would be to record the JDK initial security property JFR event. And that one we have a few options as well. So we can record this event by enabling JFR when we are starting the record. So when we're launching our application, we can start a recording with this event. And because this one is enabled by default, you just need to give the settings file with the default profile and you have it. Or you can start a flight recording by connecting to the running application from JDK Mission Control. So there are a few other options yet. We talked about changes. We had talked about the fact that we can dynamically set these properties, right? So if we can dynamically set them, how do we trace what's going to change? That's when we can use the other event, which is JDK security property modification. So the steps to do that is to enable it in the JFR configuration. And you can do that with the JFR configure command. So that works very nicely. Or after you have done that, you can start a flight recording, because if you do that first one, that one is going to modify your default profile. You can then start the flight recording with the defaults, having this second event enabled as well. And after you're done a recording, you can inspect the resulting JFR file with JCMD or JDK Mission Control. So you can always inspect this even more and look at it, what happened there. However, there are some extra tips when it comes to working with security properties. So, for example, if you find yourself in a situation that you want to configure more JFR events, you can do that by adding an extra space between each setting. So all the time you can use the JFR tool to configure your events, not just for what I said for the events earlier, but for others as well. Just say enable true, the event name, and enable true, and that's going to give you more events enabled within your configuration. You can set up JDK security property modification when launching the JVM. So if you don't want to use the JFR default configuration or the profile one, you can also do it when you start your application and you start your recording, and you just give the values with plus. So all the time you just add a comma and a plus. You can set more JFR events when, of course, you're launching the JVM with more pluses. So add more pluses. But a much more convenient way to do this is to configure each JFR event from JDK Mission Control, JMC for short, and of course, create a connection to a running JVM. And in the JMC menu, you do the start flight recording, and that's when you can configure each security event. So you can do this, and then you can export this further. So it's way easier to do it like this and export the configuration like this instead of using the JFR tool. And of course, you can inspect the evolution of the captured events in JMC all the time. If you're interested in doing that, you can always use the event browser and go to Java Development Kit and Security. So, and just to give you an overview on how the event browser would look in the case of capturing some events, we have in this case event browser that's being focused on capturing events. And in this case, where I'm highlighting the security provider instance request for an application and which security provider details were caught within my event. And you can see there the algorithm name, the security provider, and of course the type of service that was used in invoking that specific provider. This advantage of inspecting the recording in JDK Mission Control is also nice because you can see some views of the events that were caught within your sampling. So you can see here that this heat map has like 115 events recorded. And you can see which one were mostly captured and more relevant for your application. So maybe which provider is heavily used by your application. But let's look a bit also at monitoring TLS protocol, because when we talk about security, we most of the time think about applications that are accessed via HTTPS. And we find SSL/TLS important because this gives us a few aspects for our application. It ensures confidentiality for our applications, so it can protect the sensitive data that our application uses from unauthorized users. And of course, this is done via encryption and decryption. It can also check the authenticity that a user is able to access that service via certificate authorities and of course via digital certificates. And also it can ensure that the messages that we are exchanging with our users are only done in an authorized way. So there's no way that unauthorized modification of data in transit is occurring during the requests towards application. Now, to capture TLS protocol, as developers, we have a few options as well. So as developers, we can always use a network protocol analyzer tool. Like, I remember back in the day, Wireshark. So we can use that. We can attach the tool to the network interface where the JVM that we want to capture messages to is communicating it. And of course, we can manually look for the server hello record to determine the TLS version used on a particular socket. But the Java developer-friendly way is to use, once again, the javax.net.debug set with the value of SSL handshake. So this will print in the logs the TLS protocol and other additional information there in your logs. Yet, you can get more filtered logging. Another approach, as logs can be verbose, and like searching through logs, especially to an application that's in production, can be tedious. What we can do, we can configure the JDK TLS handshake JFR event to get essential TLS information from that. So, for example, let me show you how that would work. Do a little demo. Do a little demo now? No, sorry. It was too early for the demo. So, a server hello, if I am to capture it in the logs, would look like this. So on the server side, it will have this kind of output. And in this output, you see server version, TLS version 1.2. And also a little lower, there's a selected version, TLS version 1.3. Which one do you think it was selected in the TLS handshake? 1.2 or 1.3? You can shout the answer. Please raise your hand if it's 1.2. You think. Okay, so half of the room. And the rest of the half believes that's 1.3. Okay, so it was a 50-50, but actually it was the selected version, the 1.3, that was used in the end. But why is there the TLS version 1.2, right? What happened is that when the client side was involved in the handshake, they said, hey, I would prefer to use at least TLS version 1.2. So that's what the server version says there, like, hey, preferably the client would like to use version 1.2, but they said like this version 1.2 minimum, because they don't know, maybe the server doesn't support version 1.3. What the server says in the end, it says, hey, but I can support TLS version 1.3. Let's use 1.3 because both of us can use it. So in the case of logs, if you really want to analyze which TLS version your application is using and you don't have any other configuration that can give you an idea about that, you can always rely on the selected version there. So to capture protocol details within the JDK TLS handshake and like leave the logs aside, you can always use and switch the JDK TLS handshake option to true in JFR configuration file. Then you can do this by running the JFR configure command, for example. So this is what you have to run there. Now, in this case, you see that's enabled to true. And I also said I want to see the stack trace when the handshake is occurring. So I want to know what was the stack trace, what methods were invoked when the TLS handshake occurred. And last but not least, you can start a recording when a JDK TLS handshake is enabled as well. So you can also do this when you start your application with your recording and enable it. However, now is the demo time. So what have I prepared for you to demo a bit the events today? So I have a Spring Boot application that's running with JDK 22. It's actually a tic-tac-toe game, a very monolithical build. It, of course, stores the server certificates in the key store. And in order to authenticate the client, it is also using a thrust store. So in this case, because my application will run both on local, but hopefully I can deploy it somewhere else, that's why you see there a local.txt file with the DNS1, which is localhost, and DNS2, which is called Spring Boot. We'll see the connection a little later. Now, to be able to use this application, the server is going to give me a certificate for me as a client to accept and say, hey, please accept the certificate and trust me that I'm going to give you the option to play tic-tac-toe. However, before the server to do this, the client has to also give a certificate and say, hey, I'm authorized to play tic-tac-toe. And once that client certificate is received from my side, the server is going to go ahead and give me the server certificate as well. So let's see that in practice now, finally, the demo. As I said, I have a simple tic-tac-toe app, Spring Boot based, and of course, JDK 22, that's good. What else? I have configured everything for it in the application properties and is using HTTPS. So in order to use HTTPS for Spring Boot, because I'm using a Spring Boot version that's above 3.1, I have configured SSL bundles. So this was a new feature that was introduced in Spring Boot 3.1 to have SSL bundles instead of the regular, what was that, a server.ssl configurations that we're doing. The reason for the SSL bundles is because throughout the lifecycle of your application, maybe you want to change how you're going to provide your authentication and authorization to your application, and it's way easier to do it via a bundle than via the server SSL configuration. So in my case, I have a key store location to a folder called stores. Of course, you can see there the password isn't clear, but it's just for demo purposes. And as I said, as a client, I should also provide a certificate. And to do that, to have mutual authentication enabled, I have to also go here and uncomment this part with the SSL client authentication needed, and of course provide a place for my trust store, which is truststore.p12. So I want to run my application. And I lost my, oh, come on. Now my laptop blocked. Sorry. Seems that the demo guides are not working with me. Yeah, sorry. It's going to be a hard restart for the demo. This didn't happen in a while. Thanks. It's very interesting. Okay, finally it died. That's what you get when you try to do a security demo. Have to be patient a bit. It's a Mac, it loads everything. It's all memory. Okay, hopefully it goes back to where I was. Thank you. Yeah. Thank you for your patience. Promise it's going to be interesting once it works and it runs. It was it's not even all warm enough to destroy this. Come on. Seems to be done. Okay. Just give me 1 more minute to be able to restart everything. Okay, because there are a lot of things that start by default when my laptop is starting, apparently. Quit. Okay, so tick-tack. Oh, wow. IntelliJ really doesn't want to start my application. And I upgraded my laptop. Give me a moment. Okay, now we're back on track. Those were fun times. Thank you. Let me just open also the presentation. Yeah, yes, I am ready. I will not enter the presentation mode anymore, just make sure that my application is not dying anymore. And I hope that is visible enough to you. Okay, good. So let's run the application where we were. Okay, so my application has started. And as we said earlier, we're going to look at the what we have in the logs a bit. So we have the properties in the logs, the initial properties. Then we have some details about the TLS key limits, and my application has started. Okay. Now what else? I want to see if my properties have changed, and I want to see the TLS handshake. But I already started my application. So let's assume that I have forgotten to start the JDK Flight Recorder, and I don't want to profile my application just from the beginning of my application. How do I go and capture still the information? In this case, what I can do, I can say Java 22, just make sure that I'm running the Java that my application is running, and use the JCMD tool to send a diagnostic command to my application to still do a recording. So first of all, I need to find out the ID of my JVM that is running the tic-tac-toe, 5065. Let's make this clear. GCMD, and now the ID. And we can say JFR start. I also have to give some settings if I'm going to go with this approach. So to give some settings, I have prepared for myself the myprofile.jfc file, which has all the security events enabled. Now in this case, I just need to say settings, sorry. It is myprofile.jfc. Next, I have to say where to store the information. So I can say file name, record.jfr. Very meaningful in this case. And I also want to have a duration for this recording of 60 seconds. So hopefully this is going to be enough. The recording has started. Let's go to the browser. Not now. Okay. Let's go to a private window and say localhost. My application is started at 18443. Obviously, it's asking me, like, I have a self-signed certificate. Do you want to accept the risks? Yes, I accept the risk. Secure connection failed. Yeah, because, well, SSL error, bad cert alert. I haven't provided my client certificate. So the server wants to know that if it's me, that it's going to access the application or somebody else. So what I have to do, just go certificates, import my certificate for this application. Very secure password. I think you can guess it, given the previous configurations I had. And try again here. In this case, what happens is that the server received my client certificate. Now it says, hey, would you like to accept my certificate as well? And I'm like, yeah, I'm going to do that. So first of all, I need to register, once again, a very secure user and password. And then I can sign in and play some tic-tac-toe and play again if I really want to. And log out in the end. Now going back here, I want to see, yes, I have something in my recording in the record.jfr. So I want to inspect a bit what's in it. If I want to inspect, for example, the TLS events that occurred with my application, I can do that by using JFR. So Java home, bin, JFR, print, -- events that have TLS in it. And of course, I can do record.jfr. I didn't record anything. That's weird. I have a backup of the TLS thing. So it's kind of awkward that I didn't catch those events. But usually how the events look like is as follows. It contains only the information of the protocol that is being used. And in this case, it's TLS version 1.3. So it doesn't have that server version anymore that you saw in the logs. It also gives you the start time when this occurred, appeared host. But in this case, because I'm running on local host, it appears NA, which of course is my local host. And once again, the peer port is not captured. But if I would have like a DNS with a proper port, it would be captured on the peer port. It also shows which cipher suit was used in the TLS handshake exchange. This is very important because when the JDK gets improved, especially in security side, the cipher suits, they got strengthened, or some of them got deprecated and become legacy, so they should not be used anymore. So always look at the cipher suit value, because depending on that one, you can use something that it's not secure anymore. On which event thread did that occurred? And the Java thread that was there. In this case, I'm using Java thread ID 138. And of course, the stack trace that was involved in the handshake there. So this gives me information about the stack trace as well, not just about which version was in use. I would say that this one is a little bit more complete than the one that is in logs, which is usually, let me go here, server hello, which is the one that I showed you earlier with the server hello and the server version and selected version and so on. So it gives you a little bit more than this one here. Now let's go back to the presentation. Specific slide I was on. Okay. So looking back, what we did to inspect the TLS handshake via JCMD and JFR was to do the JCMD diagnostic command with the JFR start, then look at the JFR events using a print command, and of course have a result and an output like similar to this one. Now this output is actually taken from a place where there's an actual host in place, and there's a peer port of 443, and of course TLS version in use and so on. So more details. The important details that you need to observe, as I said earlier, is like the peer host name, the peer port, the TLS protocol version that is negotiated, and the cipher suit that gets negotiated with it. Also, it's important to like connect the certificate ID that was involved within the TLS handshake, because that's the certificate ID of the peer client as well. And speaking of certificates, to analyze X509 certificates, we can use a couple of more events. So why we actually care about the X509 certificates, because they include information like a public key, a digital signature, and information about the identity associated with the certificate and its issuing certificate authority. So The important aspect about them is that they have the ability of the receiver to validate the identity of the certificate presenter. And there are a few series of fields that are important to know about certificates, and that's where the JFR events help us, because the X509 certificate event gives us information about what you see here as version, serial number, signature, validity period, and subject name. So to view certificate details, you can always use keytool, for example, to check about them, but also you can configure the debug system properties to print of those certificate details there. And if you want to do that, you have to put the debug with the value of cert path. Moreover, if you want to use the X509 certificates within JFR, all you have to do is to switch them to true. So in the XML that I showed you earlier, this part is also set to true, like the enable set to true and the stack trace set to 2, to have the details of the certificate and if they were successfully validated. Now, you can also run the JFR configure as said earlier, and you can start a recording on application launch and have them on enabled there. Now, to capture details on X509 certificates with JCMD and JFR, you can always run your application with -XX start flight recording with true, execute the diagnostic command like I did earlier, and of course you can now print the events and just give the name JDK X509 certificate if you want to check the certificates. And here we have an example output for the print events in the temp JFR, but this one contains an X509 certificate event with all the details like start time, algorithm, serial number, subject, issuer, and so on. So all the details that were said earlier are captured in this nice JSON, all these details. But let's see them a little bit in practice. So I said that we're going to look a little later at the cloud as well. So to have this running in the cloud, I thought, how can I do this simple? So what I did, I made a small Docker file for my application, a small Docker file. I just used the from a JDK version to make my own custom GRE, my own custom runtime, run glink over it, so use just the modules that my application is using. And once I have this custom runtime, I can just copy my application and run my application in a container. But moreover, if I want to run it in a container, I need an orchestrator, so I used Docker Compose for that. So what I did, I said, hey, I need to use this Docker file that I created earlier, but moreover, this is on HTTPS, and obviously, if it's on HTTPS, I have to configure the key store, the trust store. But if it's remote, I need to use GMX, right? So if it's remote, I need to use GMX. I have to use, again, authentication, right? So I need a user and a password. And that's why I have GMX remote access file and the one for password that is setting the users and their access to my so-called remote application where I can use GMX and check my remote app in a container. I provided everything as a volume because this is running in Compose. And once again, the port that I can access my application on is 8443 and 1099 for GMX. So quickly, let's run this locally first. Okay, clear. Docker compose, up, -- build. So this is going to build from scratch everything. And my application hopefully will start running soon. Okay, so my application started once again. Now, this is a remote application. So since it started, I can use another tool. It's JDK Mission Control, right? And to connect remotely, I can just use the connect feature. I'm going to ignore the other connections I have. I'm going to say, well, now it's running on my local computer, so I can say 1099. I'm connecting securely, and one of my users is called admin. The password is pass1. Let's test the connection. It's all good. So now let's do a recording to this remote application. Start flight recording. Template manager, a new template. I'm going to say edit, tic, tac, toe, remote, and go to security. So, I mean, look, security, initial security, false. Well, property modification, everything's false. False. So I need to enable everything one by one. Because if I want to keep all the events in track, I can do this. Good. Okay. So I'm going to take OK. Let's go to tic-tac-toe remote. Next. And finish. So now my recording again, 60 seconds has started. Let's go once again to the browser. Click on this one. I already have imported the certificates, so I'm just going to go to a private window and see what is going on. Since it's 8443, I'm going to get there, say, OK, you have a self-signed certificate. Yes, I'm going to accept the risk and continue. Yes, I'm going to accept that Anna is allowed to authenticate against this application. But again, it doesn't remember me because I have started again the application in the container, so I have to sign in with my user and play. So now I have once again did the same thing, but in a container. Good. So let's go here. Oh, no, here. It's at 91%, 92, 95, and so on. 98, okay, 100% the recording. Now the recording is done. I'm going to the event browser, and I'm just going to try to see what's going on with the certificates. Now with the certificates, there were 11 details that were captured about my certificates. And you can find here the certificate issuer ID, and in this case is my server certificate all the time. Server certificate most of the time, and 2 times is my client certificate, which has common name Anna. Now, because there was an authentication and a validation of my certificate, both my client and the server one, there are 4 details about the validation being captured. So there is a certificate chain that has 2 certificates that in the chain there are 2 paths that are being validated. That's why you see certificate position 1 and 2. So both for client and for server, the validation chain contains 2 points in the validation path, and those are being tracked for each of those. And you can connect which certificate was in the validation chain at what point thanks to the event thread name, so 55 and 39. And if you can go here, I'm just going to sort by number, you can see 55 2 times and 39 2 times. There's always a connection between the 2, even between the details and the validation itself, thanks to the thread ID as well. So that's the part for my application running remotely. I have managed to check that. How about doing a continuous monitoring in the cloud? So now my application can run remotely. I was able to connect with JMX to a remote application running in a container. However, that's like a, let's say, an old way of working. Because before JDK 16, that's what you needed to do. You had to use JMX to connect to a remote host and profiler application like this. But since JDK 16, you can transfer recorded events programmatically. So you don't need anymore to do all this dance of JMX authentication and connection all the time, unless you want to. Because JDK Flight Recorder now also provides you an API to support event streams. And how that API looks like. You have a couple of options with working with that API. So for example, if you still want to use the JMX application, you can do this so-called monitoring active out of process, but over the network of a Java application. What this means is you have an application that has JMX enabled. You can monitor it out of its process via another application, via JMX. That's what that does. You're connecting via JMX programmatically, and you're getting the events thanks to the remote recording stream. And what you do in order to do this, you are instantiating an mBean server connection. That's one way to do it. If you still want to keep JMX, and if you want to take the events through another application out of process. Another way to do it is streaming JFR events actively within the process. So from the same application, you can stream the events to another location. And for my application, I prefer this second one because my application is active. I can open the stream of the events and I can stream them to another party, which in my case would be Prometheus. So in the slide, you can see that once the repository of events is opened, when the event is emitted, it is recorded in a gauge and served further to a metric registry. A metric registry that can be taken over by Prometheus, for example. So the demo set up, what happened? It evolved. Since I'm using Docker Compose, I can always attach a Docker file that is corresponding to Prometheus, configure it, and stream the application that I have to Prometheus elegantly. Everything being stored, every configuration being stored in volumes as earlier. Or if I am running in Oracle Cloud, where my application is running, I'm using a service, it's called Java Management Service, that it can help me with diagnosing my application and gives me some important details about performance about my application as well. But moreover, it can also give me some reports about how I can improve the security of my application and many other parts. So, apart from this, now I need you to play and observe. So you can scan the QR code and play for 2 minutes tic-tac-toe. Now, as I said earlier, the certificate is self-signed, so you need to accept the warning that it says to you, yes, I accept the warning. In this case, I didn't use mutual TLS like in the previous demo, because in that case, I should have given you 2 QRs, one with the certificate and one with the server where you can access it. So I thought to keep it simple and just have TLS enabled on server side, and that's it. So let's play for a moment. Oh, sorry. Just keep it here. So thanks to my app, I can actively stream every TLS handshake that is going on, thanks to you, to Prometheus and inspect it there. And that's why I need you to play. Also, I need to tell you that I'm not storing your data, so the user and password are stored in any memory database, and every time I restart this demo, it's lost. And I have no way to inspect them, and I don't want to inspect them, so it's belonging just to you. And if you forgot your password, you have to, unfortunately, make again a user and a password associated to it, because I have no facility yet to recover the password. Okay, so let me remove this and go to the browser. Should have enough for now. So what happened in case of my application, I streamed actively within the same process each handshake that you have done. So I can do for that an increase of JDK TLS handshake total over the last 5 minutes. And I should see an increase over the last, let's say, 5 minutes. So we started the demo at 12:13, which, by the way, the time zone of my server, it's 1:13. And you can see that it's going up and up and up. So there was an increase in TLS connections thanks to you and playing a bit with the game. So the way that the application worked is that it externalized all the information about your underlying handshakes to a monitoring tool, and you can perform various queries within it to connect it even more with other monitoring details from your infrastructure, for example, and see how that performed. Go back a little bit to the presentation. That was the part of the presentation where it's the spoken and the demo one. You can play a little bit more with the links that I'm going to give you in a moment, but what I want to share with you is that if you want to find out more about JFR, about events, about JDK tools, you can learn about those on dev.java. And we also welcome community contributions on dev.java. So you have a proposal of interesting parts of Java that you would like to find out more, you can raise a request for that specific content on dev.java content, and we can look into it and address it. You can also write it yourself if you feel comfortable enough to write that, and you'll get to several rounds of review on how to improve it and so on. And you will get published and be part of the community that's contributing to dev.java. Now we also have inside.java, where we are publishing news and what's going on new with Java, what's going to be in the next release, research that has been done regarding the JDK about performance and so on. So all these things are on a daily basis published on inside.java, so you get the news first on what's going on with the Java versions, how they evolve, and to be prepared towards what's new, but also we are looking into the past as well. So for example, if there's some security issue, like recently was the change, the challenge with the M1 chips, which, by the way, affected all the Java versions. That was also announced on inside.java as well. And there we have another channel where we are giving news and in detail coverage about features of Java. Our YouTube channel, youtube.com/Java. We are doing live streams whenever there's a new Java release, so that we're having guests and important experts that can talk about what's going on in the new release of Java, how you can take advantage of it, what you should pay attention, and many more. And of course, the presentation has a part of useful links. So there's a written article about what I showed you today. It's on dev.java, obviously. There's also a video on JFR that was done by my colleague, Billy Corando. And of course, there is the code that I used during the demo, the tic-tac-toe application, and how I set up my remote instance using Java. So even for the instance that I have in the cloud, I use Java to create my infrastructure. And of course, how I can use Podman Compose in the remote Java, in the remote virtual machine for my application. But if you're interested also into more custom JFR events, I can recommend you the article that Gunnar Morling wrote. So it's a great article on how you can create your custom JFR events if you want to do more. And you got all of this at slides. Thank you very much for listening to me. I'm going to leave this for a while. I know I'm a little bit over the time. And then I'm going to take your questions. Thank you. Yeah. Okay. So, it's fine. No more internet. Okay. So there are a few questions that came from the audience. There was a question about when do we use key store and when do we use a trust store. So the key store is when we used to store keys, certificates, and other details about us, about the server, and the trust store when we need to establish the identity of the client. So whenever we need to establish things regarding to our the clients that have access to our application, we are using a trust store. So in the case of my application, I used both for the first demos because it was mutual authentication, both client and server. And in the second part, I just went for the server authentication, and in that one, I needed only the key store. Sorry, I need the, sorry, the sign was off. And there was another question about FIPS. FIPS mode restricts the usage of a few algorithms. Is there any tools to validate the algorithm usage with respect to FIPS? FIPS mode restricts the usage of... so if you want to check which algorithms are being restricted for your application, most of the time by a Java application, make sure that those are according to FIPS. The first thing that I'm thinking about is to look in the security file configuration and see which algorithms are specified to legacy or the disabled parts for different parts of your application. And check that against the FIPS. That's how I would personally do it. Like, check if there's more restriction going on from FIPS side compared to what's already provided by the JDK. Now, the conf security file that the JDK is coming to is more like a guideline. So there are algorithms that are considered legacy. There are some that are others that are disabled. And those are actually the best practice, and that applies to the wide variety of Java applications. However, if you are under more constraints at work, and that requires for more restriction over algorithms, you can add more algorithms to those areas and restrict even more algorithms down the road. So you can even be more strict. Another way to do it, frameworks also have a way to restrict which algorithms are being, or cipher suits, for example, are being used within setting up HTTPS. So I've seen that Spring Boot, for example, has a way to enable certain cipher suits and work with only specific cipher suits for our application. So check also what the framework is enabling you through their properties as well. Hope that addressed the question. Sorry, it blocked again. Thank you. And of course, you can find me at the Oracle booth. I'm going to be there starting 3:30 for a while, and also tomorrow. So hope to see you more and talk more about Java security and other stuff. Thanks. Thanks.